Today we're going to make an observation that was first observed last time with the numbers increasing and decreasing while computing the combinations. This pattern is what we call Pascal's triangle. So as indicated, we're going to be looking at a triangle, and we're going to start by taking the numbers 1 and 1. Next, we're going to take 1, 2, 1. And how do we get this? Well, the first and last number of each line should be 1, and the terms in the middle are gotten by adding the two terms above. So for instance, we have 1 plus 1, which gives us 2. The next line will be 1, 3, 3, 1. The first and the last terms are 1, and then by adding the two numbers above the 3 together, we get 3 in each case. The next one would be 1, 4, 6, 4, 1. We get the 4 by adding the 1 plus 3. The 6 together we get by adding the 3 plus 3, and then the 4 is 3 plus 1. And then the next line would be 1, 5, 10, 10, 5, 1, and the pattern continues. So what is this number? Well, we can relate it to the combination of n choose r by taking n to be the row number. So for instance, the first row is when n is equal to 1, the second row is when n is equal to 2, and so forth. And then we can have r, which is the diagonal that it's represented. So when r is equal to 0, we have the first diagonal, r is equal to 1 is the second, and so forth. So if we're trying to compute 4 choose 2, we want to go to the fourth row and to the third diagonal, and we find that those two numbers intersect at 6. So therefore 4 choose 2 is 6. When we compute 4 choose 2 using the formula from last class, we get 4 factorial over 2 factorial times 4 minus 2 factorial, which is 4 times 3 times 2 times 1, all over 2 times 1 times 2 times 1. And that simplifies to 6. Alright, this gives you a pretty neat way to compute when we have n choose r. As an aside, you might have seen Pascal's triangle with polynomials, and if you're interested, I encourage you to look up Pascal's triangle for other uses.